and next week we can start the probability. Okay, so don't worry. Uh, Please try this question by computing. But Nabil, the problem is you have also not submitted the homework yet. So I'm worried about the second part. It is tough, and no one has completed any assignment. Means you have done only some assignments, not all. By computing the shortest distance, determine whether the determine whether the following pairs of lines intersect or not. Okay, so yesterday we have done the formula of shortest distance. With the help of that, you have to solve this question. And the question is x minus 1 by 2 is equal to y plus 1 by 3 is equal to z. Okay, and second line is x plus 1 by 5 is equal to y minus 2 by 1. And the problem is here they have given the comma. Okay, here they have given the comma z is equal to 2. It is not equal to, okay? In the first equation, it is equal to, while in the second equation, they have given the comma. So, and this question came in CBSE 2020. So such type of question we have done earlier. First of all, change this in the standard form and then solve this question. Atif, we have just started this question, okay? So by using the shortest distance, check these two lines intersect or not. Here we have a comma. Please take care of this. Try this. Let me know if anyone have a doubt. Atif, please tell me what the standard equation you are getting for the second one, second line. Okay. Atif, did you get the standard form for this line?
No, sir, I'm doing.
Okay. Nabil, once you get the standard equation of the second one, please share with me. Then only solve the question. Okay. Seth, you are 14 minutes late. What's the reason? Yes, Seth, you're 14 minutes late. Please reply me on the chat box, okay, Seth, and start this question.
Okay, sir.
That is the standard equation for x plus 1 by 5 is equal to y minus 2 by 1 is equal to z minus 2 by 0.
Very good, Atif. It is correct. Now, please continue this question, okay, and share the final answer. Seth, please note in this second equation, it is comma, okay? It is not equal to. So please convert this in the standard form. This we have already done in the previous classes. So please convert this as, in the standard form. Share your answer with me. Then start doing the question. Okay. First, tell me what
Okay,
is the
sir.
standard equation. Okay.
Sir, I'm getting x plus 1 by 5 equals to y minus 2 by 1 equals to z minus 2 by 0.
Very good, Saf. That is correct. Now the question is, you have to show that you have to check that the line intersect or not by using the shortest distance method. Okay. So I hope you can do this on your own. Please complete this and share your answer. It came in CBSE 2020.
Done.
Okay, so Atif, the lines intersect or not?
So they do not intersect.
Yes, Atif, they will intersect or not?
They do not intersect.
They do not intersect. Very good. Seth, please let me know once you get the answer. Seth, is it done?
1 minute, sir.
Nabil, if my voice is audible, please let me know if you have completed this. Okay. Seth, please complete it fast. We have to start the new chapter today.
Yes, sir. They don't intersect.
They don't intersect. Very good. Good. Nabil, please complete it. Okay. And share your answer with me. I need to start the next topic because half an hour has already been passed. Okay. Now, the next topic is distance between distance between two lines. Parallel lines. Okay. Now remember one thing. Whenever lines are parallel, if lines are parallel, if lines are parallel, then they are coplanar. Then they are coplanar. Okay. If lines are parallel, then they are coplanar. What are coplanar lines? I will write here. Coplanar lines. Lines are said to be coplanar. Um, or I will write here only. Okay. Lines which lie on the same plane. Lines which lie on the same plane. Lie on the same plane. Okay. So if lines are parallel, then they are coplanar. Coplanar means they lie on the same plane. What is mean by on the same plane? Just take out a sheet of paper and draw the lines in that. So any number of lines which lie on that sheet of paper are said to be coplanar. Okay, because that is one plane. In that plane, whatever the lines you will draw, those are said to be coplanar. Okay, I hope coplanars is clear to all of you. What are coplanar lines? The lines which are lie on the same plane. Okay, so I'm saying if lines are parallel, then they are coplanar. Okay, now I will write the equation of two lines. Line L1. So let this be R is equal to A plus lambda B. Okay, who can tell me what is B? Saf, what is B? What is B
A
here?
vector that is parallel to A.
That is parallel to the line. Okay, not A. Okay,
Yes,
B
sir.
is a vector which is parallel to the line. Now, here we are drawing another line. So I will take the position vector A2 plus new and I will write B here. Why I am writing B? Because we have two lines. Just one. These two are parallel. Suppose this is L1, this is L2. These two lines are parallel. If this line is parallel to vector B, then vector B is also parallel to line 2, to line L2. That's why I'm writing B here. Okay. Please check this. Why I'm writing B in both the lines? Because the lines are parallel. So if there's a vector B which is parallel to this line, then the same vector will be parallel to another line. Okay. Now, and always remember, if you are getting a question, okay, if you have an equation like this, A can be anything, A1 can be anything, plus lambda. For example, here they will write 2i cap plus 3j cap plus 4k cap. And second equation, they will give you like this, R is equal to A2 plus new. And here they will give you 4i cap plus 6j cap plus 8k cap. Then what you need to do in this case, take out two common. These two should be same, then only you can apply the formula for this one, distance between the parallel lines. These two lines are same, sorry, these two lines are parallel. Why there's a difference in B here? Because they have multiplied this with 2. So take out two common. Okay. This formula you will always apply when these two are same. So please take out common first, make these two same, then only apply the formula. Now the distance is what? So I will draw the line here. Okay, this is your first line. This is your second line. And these are parallel. I will draw perpendicular here, like this. Okay, this is L1. This is L2. This is a perpendicular. There's also a perpendicular. Okay, let this be AB. So we need to find AB. Okay, perpendicular distance. So distance we are calculating here. Distance D is equal to here B cross product A2 minus A1, okay, by magnitude of B, and take the modulus of this. Take the positive value always. Okay, so what you need to find here? B cross A2 minus A1 by magnitude of this and take a modulus of this. Okay. So I hope this is clear to everyone. Please note down this, raise your hands once it is done, then I will give you a question on the basis of this. Yes, I have good. Atif, is it done? Nabil, is it done?
Done.
Oh, okay,
Yes,
okay.
sir.
Okay, great. Now, please try this question. Okay. Question is find the shortest distance. Find the shortest distance between the lines. Between the lines. Between the lines whose vector equation are whose vector equations whose vector equations are okay. The question is r is equal to I cap plus 2j cap plus 3k cap plus lambda 2I cap plus 3j cap plus 4k cap and r is equal to 2I cap r is equal to 2I cap plus 4j cap plus 5k cap plus new 4I cap plus 6j cap plus 8k cap. And this question came in CBSE 2008 and 15. Okay, so please check this question. They have not given that these two are skew lines or not. Okay, so please, whenever you are getting a question, please check this B, that these two are skew lines or these two are parallel lines. So you can see here these two are same. They have just multiplied with 2 this one. So take out that 2 common. So this is a distance between the parallel line. So please focus on B. In exam, please don't take this as a skew lines. Okay, I hope everyone understood the difference between the two, distance between skew lines and distance between the parallel line. So the hint you will get from the vector B here. Okay, so now please try this question and share your answer.
Sir, is it 16 by root 29?
16. No, it is root 5 by root 29. Okay. So what you're getting that B cross A2 minus A1, Atif? What's the vector that? B cross A2 minus A1? Atif, what is B cross A2 minus A1? Please reply me on the chat box, okay? Seth, do you get that B cross A2 minus A1?
No, I mean, sir.
You're doing?
Yes, sir.
Okay. So please take out 2 common from this. Then you will get B, this one only. 2I cap, 3J cap plus 4K cap. Then apply the formula. Nabil, is it done? Nabil, is it
Yes,
done,
sir.
Nabil? What you're getting this?
Yes,
B,
sir.
yes. What you're getting this one?
Uh,
Anyone who get this one, B cross A2 minus A1, please let me know. Okay.
Sir, is it under root 12?
Under root 12. No, there's in vector form. Can you tell me what you're getting this one?
One answer.
Sorry.
Just a minute, sir.
Oh, okay, okay. First, you need to find A2 minus A1. So subtract these two. Then you have to find the cross product with B.
Sir, B cross A2 minus A1, I'm getting minus 10I plus 4J plus K.
It's not correct. B, you have taken this 2, 3J, 4K.
Yes, sir.
Okay, so let me show this to you. B cross A2 minus A1. So B cross A2 minus A1 is equal to, what is B? B is this. Okay, take out 2 common from here. So this will also be a B for you. 2I cap plus 3J cap plus 4K cap. Okay, cross product A2 minus A1. So subtract this. 2 minus 1 is I cap. 2J cap plus 2K cap. Okay, now find the cross product. So it is equal to, right, IJK, I cap, J cap, K cap. It is 2, 3, 4. It is 1, 2, 2. So it is equal to I cap. So it is 6 minus 8 is minus 2. Then minus J cap. Then 2 to 4 minus 4 is 0. Plus K cap. So 4 minus 3. So this will give you minus 2I cap plus K cap. Is it clear, Seth?
Yes, sir.
Okay, then please use this one and solve this. Okay, find the distance and share your answer, all of you. You have taken a lot of time in this question. Please complete this in 2-3 minutes and tell me the final answer.
What is it? Root 5 by 29.
Yes, Atif, that's correct. Good. Nabil, Saf, what the answer you're getting? Nabil and Saf, what the answer you're getting?
One answer.
So I'm getting 2y minus k by root 29.
Yes, take the magnitude of this here, this one. Okay, you have to find out the magnitude of this one also. Okay, numerator also. So this distance is distance is equal to this one, magnitude b cross a2 minus a1 by magnitude of b. Okay, so this will give you this minus 2i cap plus k cap by magnitude of b. So take out its magnitude here, minus 2i cap plus k cap. Okay, and its magnitude you already know, it is what is this? Root 29. Okay, this is root 29. Find its magnitude. So it is minus 2 square plus 1 by root 29. So here you will get minus 2 square means 4 plus 1 is root 5 by this is under root 29. Clear, Seth?
Yes, sir.
Okay, Nabil, you're also getting the same answer?
No, sir. It is one answer.
It's not matching?
Yes, sir. I tried one more time.
Please check the steps, Nabil. What's the issue? You're getting this b cross a2 minus a1, this one, minus 2i plus k.
Okay, sir. Now I got it.
Okay, great. Okay, so this was the last topic. Now I will tell you what the topics which CBSE has deleted this year. So the major changes in this chapter is the topic plane. Okay, they have deleted that complete topic. So please take out your NCRT and mark in that. I will tell you the page number. So in this 3D, the plane has been deleted. Okay, topic plane. Topic plane is deleted here. Okay, it is deleted. So it is there on page 479. Take out your NCRT and mark in that. On page 479, we have a plane which is deleted. So on the basis of this topic, we have this exercise 11.3. Okay, this complete exercise has been deleted. This was a very lengthy topic, the plane, and this year the CBSE has deleted the complete topic. Okay, so delete this complete exercise 11.3. This is completely deleted. After that, come on at page number 496. So there are some examples which you don't need to do now. Sorry, it is, yes, it is page number 495. Okay, page number 495. Example 27. Example 27. It is better if you will mark this in NCRT. Delete this example. No need to do this. After this, page number 496, example 29. Example 29, it is also deleted. Okay. This, if you will see any question based on this coplanarity of lines, of two lines, if you will come across any question like this, leave that question. It is not in the syllabus. This is completely deleted. Okay. After that, come on at miscellaneous. In miscellaneous, page number 498. Page number 498, question number, let me check this again. So in miscellaneous, in any question, if you're getting a plane, that question belongs to plane, then please delete that question. For example, question number 7, miscellaneous, page 498, question 7th, question 8th, question 12th, question 13th, question 14th, question 15th, question 16th, 17th, 18th, 19, 21, 22, 23. All these questions are deleted. Okay. So this complete topic, the plane has been deleted. On the basis of that, from the miscellaneous, we have cut these questions because in that we have to use the concept of plane. Okay. So just right now, please mark this in NCRT. Other than this, we have to do all the topics. So our chapter is completed. We have done all the topics. Okay. Please mark this. So in this chapter, basically we have a straight line and a plane. So complete plane needs to be deleted, and a straight line we have done. Okay. Now note down this. Raise your hands once it is done. Then we will start the linear programming. Okay. And hopefully till next Saturday we will complete linear programming and can start the probability. All of you, please raise your hands once it is done. Is it done? Nabil, Atif, Saf? Nabil, Atif, Saf, we have to start a new chapter. Is it done?
Yes, sir. Done.
Okay. Saf, is it done? Saf and Nabil, is it done? Done, Nabil? Saf, is it done? Shall we move to next? Okay, I will consider your
Yes,
silence
sir.
as
Yes, sir.
yes. Okay, great. Now we will start the linear programming. Okay, next chapter. Okay, and rest of the question you have to do. So the homework is in this chapter. Assignment 1 I have already given you. Assignment 1 complete. Assignment 2. Assignment 2. Okay, and then assignment 4th. Assignment 4th, and from the assignment 4th, please delete these questions. Maybe these questions are there in the assignment. Please delete this. So in any question, if you will come across a planes, then don't do that question. Okay, and share your homework with me. Now we will start the linear programming. It is a very simple topic. Okay, so we can say that this is a bonus chapter. Now in linear programming, please mark on the page number 519. Page number 519, there is exercise 12.2. This complete exercise has been deleted. Miscellaneous, miscellaneous deleted. So there is only exercise 1 which we have to do. So basically in this chapter, we have to, in this exercise, there is a word problem. We have to make the equations and then we have to solve this. Okay, so there is no need to do the exercise 12.2. Word problems they have deleted from the syllabus. Now you will get the equations only, and the equation you have to solve. in this chapter, you have to solve the equation. So there's a single exercise. So hopefully we can complete that today. And next Saturday, we can start the probability. Okay, so I will just give you 1 minute. Please complete this, note down this or mark this in NCRT. Raise your hand. Then we will start this linear programming chapter.
Yeah.
Okay, I think this is done. So let's start next. Next, we will start this chapter. It is linear
And
programming.
sir, what is the other part that is deleted?
Just give me a minute. Yes, the exercise is deleted and miscellaneous exercise. Complete miscellaneous is deleted because in miscellaneous you can see there is a word problem. Okay, so we don't need to do the word problem from this chapter.
Yes, sir.
Okay, so cut this exercise, cut the miscellaneous exercise. Now we will start next linear programming. Okay, okay. So first of all, I will tell you some terms which we will use in this chapter. Then I will give you a question and I will solve it. So if you understood a single question, then you can solve the complete chapter. Okay. So in linear programming, first is, I will say, the objective function. Objective function. Okay. What is the objective function? Linear function. Linear function. Z is equal to ax plus by. Linear function z is equal to x plus by, where a, b are constant, where a, b are constant, which has to be, which has to be, which has to be maximized or minimized, which has to be maximized or minimized, is called, is called a linear objective function, is called a linear objective function. Linear objective function. Okay, so we will take example. For example, the cost of a chair is rupees 50. Okay, and the cost, this is of the cost of chair, and this is suppose table, it is rupees 100. Okay, so this is price per unit, and I will say the profit. The profit on the chair is, for example, 10, and profit on the table is 20. Okay, so if you want to if you want to sell a chair and a table, okay, then what we wish to maximize the profit. We wish that our profit will be maximum. So this profit is called the objective function. For example, if you will buy X chair and Y table, then what the profit you will get? 10x plus 20y. Okay, so what is the objective function? Any function which needs to be maximized or minimized. That is called a linear objective function. Okay, so we will see in the some questions. For example, profit, you want to maximize. If you are facing a loss, you wish that your loss will be minimum. So this profit, loss, all these are the objective function. Is it clear? Atif, Saf, Nabil?
Yes, sir.
Sir, can you repeat once more?
Yes. What is a objective function? Any function which needs to, which you wish you needs to be maximized or minimized. Okay. So for example, if you're selling a chair, I will say chair and table. Okay. And if you sell a X chair, sorry, one chair, then your profit, suppose it is rupees 10. If you will sell a table, then your profit is 20. Suppose you're selling X chair and Y table, then what will be your profit? 10x plus 20y. Okay, this is it. So what you need, what you wish, your profit should be maximum. If you're selling chair and a table, then you want that your profit will be maximum. Okay, the linear function which needs to be maximized or minimized. For example, if you were facing a loss, then you need to so the function which needs to be maximized or minimized, that function is called the objective function. Is it clear, Atif, now?
Yes, sir.
Atif, is it clear?
Yes, sir.
Okay. Okay, so this is the objective function. Uh, Please note down this, raise your hands, then we will start the next topic. Atif, Saf, Nabil, is it done? Shall we start next?
1 minute.
Okay.
Yes, sir, done.
Okay, so I hope everyone has done this. So you understood what is the objective function. Next is constraints. Next is constraints. Okay, so the linear inequalities, the linear inequalities or equations, the linear inequalities or equations or restrictions on the variable on the variable of a linear programming of a linear programming a linear programming problem are called are called constraints. Okay, so what is a constant? The linear inequalities or equations or restrictions on the variable. So for example, in the previous case we have taken for example chip profit profit was 10, on table the profit was 20. We were selling X quantity of chair and table Y. If I will say to you that you can't sell more than collectively, you can't sell more than 40. If I will say that you can't sell more than 40 table and chair collectively, so you will write X plus Y less than 40. Okay, so this is your restriction. This is your restriction that you can't sell more than 40 table and chair. Okay, so such restrictions or such inequality or such equations are called the constraints. So what are the constraints? The restrictions on the variable. For example, here I've given you the restriction that the table and chair should not be more than 40. Okay, so you will write X plus Y less than 40. So this is called the constraint. So the restrictions on the variable, that is called the constraint. Okay, and normally in each and every question they always give two restriction like this: X is greater than equal to 0 and Y is greater than equal to 0. That means the chair or table which you are selling, that should be greater than equal to 0. Okay, so basically you can't sell a quantity which is negative. So that's why we always write X is greater than 0, Y is greater than 0. So table and chair should be greater than equal to 0. And these are called the non-negative restriction. So I will write here. When we will start the question, then these terms will get clear to you. Okay. Here the condition x is greater than equal to 0, y is greater than equal to 0 are called non-negative restriction, are called non-negative restrictions. Okay. So these are the constraints, and these are called the non-negative restriction. X is greater than equal to 0, y greater than equal to 0. Okay, please note down this. Again, raise your hand, then we will start next term. Okay, Nabil, good. Atif and Saf, is it done?
1 minute, sir.
Okay. Saf, is it done?
1 minute, sir.
Okay, okay. Saf, is it done?
Yes, sir.
Okay. Now next one. Next is optimization problem. Optimization problem. Okay. A problem which seeks to maximize or minimize a linear function subject to certain constant uh, as determined by a set of linear inequality by a set of linear inequality is called an optimization problem. It's called an optimization problem. Okay, please write this. A problem which seeks to maximize or minimize a linear function, that is the objective function. Okay, and subjected to certain constraints. So a problem in which we have to maximize or minimize the objective function under certain restrictions. Certain restriction means constraint. That is called the optimization problem. Okay, please note down this. I will again explain this to you when we will start doing the questions. Okay, that will be more convenient for me. Please let me know once it is done. Is it done? Atif, Saf, Nabil?
Yes, sir, done.
Yes, sir.
Okay. Next is linear programming problem. One more definition. Linear programming problem. Okay. So what is linear programming problem? It is the one. It is the one. It is the one that is concerned with that is concerned with finding the with finding the optimal value, finding the optimal value. Okay, optimal value means maximum minimum value, maximum or minimum value of a linear function. Linear function means objective function of linear function. Okay, in this case the linear function is what? It is an objective function. We have to maximize or minimize the objective function of several variables of several variables, say x and y, subject to the condition, subject to the condition that the variables are non-negative, are non-negative and and satisfy a linear inequalities, satisfy a linear inequalities. Okay, here we are using linear. That means whatever the equation you will get in this chapter, that is linear, that is a degree one. Okay, so what's a linear programming problem? It is a problem where we are concerned with finding the maximum or minimum value of a function. Which function? Objective function. Okay, and but we have conditions which are constants. Okay, subject to the conditions on the variable. That means there will be some constant under which we need to maximize or minimize a problem. Okay, please note down this, raise your hand, then there are some more definitions, then we will start the question. Okay. Is it done? Atif, Saf, Nabil, shall we start next? Atif, is it done?
Yes, sir.
Okay, Saf and Nabil, shall we start next?
Yes, sir.
Yes, sir.
Okay, great. Now next term is visible region. Visible region. Okay. So the common region, the common region determined by all the constraints, by all the constraints, including non-negative constraint, non-negative constraints, x comma y greater than equal to 0 of a linear programming of a linear programming problem is called the visible region. It's called the visible region. Okay, so constant we have already discussed. So when we will find the common region, okay, by all the constraints, so such common region is called the visible region. Okay, so if suppose I will give you this constraint greater than 50, 2x minus y less than 40, when you will draw the graph by using these inequalities, by using all the inequalities, that common region is called the visible region. Okay, and the region other than, next I will write the invisible region. Invisible region. Okay, what is the invisible region? The region other than visible region, visible region is called an invisible invisible region. Okay, the region other than visible region is called the invisible region. All of you, please note down this. Raise your hands once it is done. Then we will check some more definition and then start the question. Is it done? Atif, Sef, Nabil, is it done? Atif, Sef, and Nabil, is it done?
Yes, sir.
Yes, sir.
Okay, great. Now, this is invisible region. Now, after this, we have a visible solution. Visible solution. Okay, what is visible solutions? Within, points within, and on the the points within and on the boundary of the visible region, on the boundary of the visible region represent visible visible solutions of the constraints. Okay, so what are visible solutions? All the points within which lie inside the visible region or on the boundary of the visible region represent the visible solution. Okay, please note down this and then confirm me. We have some more terms. After that, we can start the question. Okay.
So what is REP?
What is REP? Can you tell me the full form of this? Seth, can you tell me the full form?
Sir, he's asking what represent.
Sorry, Nabil, your voice is not clear.
Sir, he was talking what represents the second line of feasible solutions.
Oh, okay. Sorry. It's a represent. I thought you have a doubt. Okay. So please confirm me once it is done.
Done, sir.
Okay. Is it done, Seth?
Yes, sir.
Okay. So Atif, I think you have also completed this. So some more definition. Next is optimal feasible solution. Optimal feasible solution. Okay. So what is this? Any point in the feasible region, any point in the visible region that gives that gives the optimal value that gives the optimal value. Okay, that means maximum or minimum of the objective function of the objective function is called an is called an optimal solution. It's called an optimal solution. Okay, so any point in the feasible region that gives the optimal value, maximum or minimum value of the function is called the optimal solution. Now, for example, you have some constraints, and with the help of this, you are drawing a graph. Okay, so suppose you get a graph like this. This one. This is your graph. Okay. So with the help of the constraint, we will draw the graph, and you have the objective function z. You need to maximize or minimize this. So how to maximize or minimize this function z? So we have a theorem by which we can maximize or minimize it. So first is theorem 1. Okay. So theorem 1 is let R be the feasible region. Let R be the feasible region. for a linear programming problem, and let z is equal to ax plus by be the objective function, be the objective function when z has an optimal value, when z has an value, optimal value means maximum or minimum. This optimal value, must occur at a corner point, at a corner point of the visible region, corner point of the visible region. Okay, what is mean by this? So you have drawn a graph, you have these points, this, this, and this. These are the corner points. So if you need to find the maximum or minimum value, you will get the maximum or minimum value at the corner points. Okay, so how to draw the graph, that we will see later on, but this is a theorem that when you will draw the graph, then at the corner point only you will get the maximum or minimum value. So we have to draw the graph, we have to find the corner points, we have to put in the objective function, and we need to check what is the maximum or the minimum value. Okay, please note down this, confirm me, then we will check the second theorem. Is it done? Atif, Saf, Nabil, is it done?
Yes, sir.
Okay, Saf and Nabil, is it done?
Yes, sir, done.
One,
Okay. Okay, Nabil. I think Nabil, you have also done this. So this is the theorem one, that the maximum or minimum value will occur always at the corner points. Next, we have a theorem two. Theorem two.
sir, could you go to the previous slide? Just a minute.
Yes, Nabil.
Done, sir.
Okay, Nabil. Next, theorem 2. Let R be the visible region. Let R be the visible region for a linear programming, for a linear programming problem. And let Z is equal to AX plus BY. AX plus BY be the objective function. Be the objective function. Okay. If R is bounded, first part, if R is bounded. Okay. If R is bounded. So what is mean by bounded and unbounded? Check this graph. I will draw two graphs for you. So first, for example, this. So this is a bounded. Okay. If I will say this is your visible region, then you can see it is bounded. There's a boundaries around the visible region. Now suppose if we have a graph like this one, but I will say that your visible region now it is this one. This is your visible region. Then this is unbounded because the visible region do not have the boundaries, so it is unbounded, and this is bounded. Okay, so I hope this is clear to everyone that what is mean by bounded visible region and what is mean by unbounded visible region. So first case I have taken if R is bounded. Okay, so if R is bounded, then the objective function, then the objective function, then the objective function Z has both a maximum and has both a maximum minimum and minimum value on R, and and each of these each of these occurs at a corner point, at a corner point of R. Okay, so what is the theorem? If R is bounded, for example this one, like this. Okay, this is the visible region. If R is bounded, then the objective function will have both maximum and minimum value. Remember this. If R is bounded, then the objective function has both maximum and minimum value. Okay, and where the maximum and the minimum value occur, as per theorem 1, it always occur at the corner point. Okay, next is second point. If R is unbounded, if R is unbounded, okay, then a maximum, or a minimum value of the objective function of the objective function may not exist. May not exist. Okay. However, if it exists, it must occur at a corner point. At a corner point of R. Okay, so what is mean by this? If R is unbounded, if your feasible region is unbounded, then there are chances that a maximum or minimum value may not exist. Okay, if R is bounded, then always maximum and minimum exist. If R is unbounded, then there are chances that a maximum or minimum does not exist. Okay, but if it will exist, if it exists, then it always occur at a corner. Okay. Please note down this. After this, I need to give you an algorithm how to solve the questions. Then we will start the question. Okay. Please note down this. And is it done? Saf and Nabil? Saf and Nabil, is it done?
Yes, sir.
Saf, is it done? Saf, is it done? Shall we start next?
Yes, sir, done.
Oh, okay. Then now we will see the method of solving this problem. So this method is called the corner point method. Okay. This method which we will discuss now is called this method of solving linear programming problem. Linear programming linear programming problem is referred as is referred as corner point method. Corner point method. Okay. And these are the steps. These are your steps. The first step is find the visible region. Find the visible find the visible region of the linear programming problem of the linear programming of the linear programming problem and determine and determine its corner points. Determine its corner points. Okay. Second, evaluate the objective function. The objective function z is equal to ax plus by. Okay, at each corner point, at each corner point. Okay, let capital M and small m denote the largest denote the largest and smallest, largest and smallest values of these points. Okay, now first is when the visible region is bounded. If the visible region is bounded, then m and small m are the maximum and minimum values, are the maximum and minimum values of z, okay. Please note down this again, let me know, then I will change the slide. Okay, this is the last theoretical part, then your theory is over, we can start the questions. Okay, please complete this. Is it done? Saf, Nabil, Atif?
Yes, sir.
Okay, Saf, is it done?
Yes, sir.
Okay, Atif, I think you have also done this. So now the second point, in case the visible region is unbounded, in case the visible region is unbounded, then we have 2 points. If the bounded, then no issue. Small m and capital M are the minimum maximum value. If it is unbounded, then m is the maximum value of z if the open half plane determined by ax plus by greater than m has no point no point in common with the visible region with the visible region. Okay, otherwise z has no maximum value. Okay, I will again explain these points to you. Sorry, I will explain this point to you when we will start doing the questions. Just note down this. Okay, similarly, m is the minimum value, is the minimum value of z, minimum value of z if the open half, if the open half plane, if the open half plane determine, if the open half plane determined by ax plus by less than m has no point, has no point in common, in common with the feasible region, with the feasible, with the feasible region. Otherwise, otherwise z has no minimum value. Otherwise, z has no minimum value. Okay. Please note down this, then your class will be over because we don't have a time to start a question. In next class on next Saturday, we will start the questions. Okay. So please complete 3D till next Saturday. And on Saturday and Sunday, we can complete this chapter and can start even probability also. Okay. Please note down this, raise your hand, then we will end the class. Is it done? Saf, Atif, Nabil?
1 minute.
Okay.
Yes, sir. Done.
Okay, Saf, great. Nabil, Atif, is it done?
One minute.
Okay, okay, okay. Okay, Saf, so if you wish, you can drop, okay? Please complete 3D.
Yes, sir. Thank you.
Okay, okay, you're welcome. Atif, is it done?
Yes.
Okay, okay, Atif, then if you wish, you can drop, okay?
Thank you.
Okay, you're welcome.
Yes, sir.
Okay, Nabil, good. Then, okay, Nabil,